Hello, I'm Tomas,
I'm Daniel.
I'm Matthias.
and we worked on a yellow light detection and warning system.
Do you ever get that feeling when you're about to cross the traffic light and the green light turns from green to a yellow and you're not sure whether or not you should stop or you should keep going through the light? Well, you're not alone in that feeling. Knowing when to stop or to run a yellow light is fairly difficult and is up to the driver to decide when to stop or continue. Yellow light timing can be confusing and often a safety issue. Drivers and passengers are at risk of harming themselves if they decide to slam the brakes before a yellow light, and pedestrians are at risk if drivers decide to continue after a yellow light as well. More than 50% of fatal and injury crashes occur at or near an intersection, according to the Federal Highway Administration. Drivers are 3 times more likely to push through a light for every extra second a light stays yellow, according to the Ohio Department of Transportation. And 76% decrease in traffic violations with an increased yellow light by half a second. All of these statistics show that there is a big issue around lights. So how can you make drivers smarter about their decisions?
So the Institute of Transportation Engineers has adopted the following formulas for a safe stopping time for a yellow light. And almost every jurisdiction in the world uses these formulas to determine some kind of stopping distance in some capacity. So the way that we decided to use was a more safer time interval formula that allowed us to adjust based on certain factors in the environment. For example, it uses a precise expression for the contribution of Earth's gravity towards a vehicle's deceleration on a hill of grid G. It also assumes that drivers are driving at or above the speed limit, whereas previous formulas only looked at the speed limit. This formula can be used to advise a driver when to stop before a red light, whereas others may stop in between intersections. So we developed a program in Python that predicts this interval based on geospatial data collected from Google Maps and OpenStreetView's API. And this calculates a directional vector of the car based on their GPS coordinate, as well as other factors in that area.
So our team began development on a light detection system using a camera. It was a light filtering camera, and the software that was used was called GRIP, which we used to filter out the peripheral light. When a yellow light is detected, an output signal would begin to calculate the distance based on geospatial location and how far away the light is, and if the car could move across the light. Given more time, the system would be integrated with the prediction system. Instead, we decided to test using simulations.
Simulating our prediction system in Unity 3D, we were able to tie the traffic light to mimic a real light, and we ran tests across the light at certain stopping distances using our prediction. In a few tests, we found that the prediction system gave reasonable estimates for how much time there was left to cross the light. This is still left to be tested more rigorously under different conditions.
So some of the limitations we faced was when we were developing our system was that, these systems would need places with good access to the internet. Otherwise, they would need to be integrated into the cars themselves. This would function the same amount of time as a GPS would. And there are also certain obstructions between the light system and the car itself that we weren't able to consider in our time. And the simulation that we ran only covered flat grades.
This doesn't even scratch the surface of the problems faced with yellow lights. Interference between the light and the car can decrease the effectiveness of these systems. Many cities also decrease the time of yellow lights below the standard timing to increase the number of red light tickets. And pedestrians may decide to look at yellow lights as a sign that they can start crossing, when in reality, left turn signals and other traffic conditions can deny them right of way. Thank you very much for listening.
Thank you.
Thank you.